Okay, this is the second part of the video. We have to talk about the characteristics of quadratics. Alright, so this is the back of your page. We just completed this page right here. Your page, when you submit it, remember it has to look exactly like mine. So now let's move on to this one. Characteristics of quadratics. Alright, so let's read what it says right here. It says, describe how the quadratic parent function is transformed to obtain the graph of g of x shown on the left. Remember, every time you see this, g of x, think of this as y equals. It can be f of x, but this one, if you see, instead of calling it f of x, we're calling it g of x. Same thing. It can be called g of x. It can be called t of x. We can use several letters. All right. Now we have this graph right here. The parent function. What do you remember about the parent function? The parent function is the basic function. For the quadratic function, this parent function is the y equals x squared because it's the basic. All right. Now let's highlight. The y-axis is right here. Let's highlight the x-axis. Look at what they're asking us to find here. Vertex, axis of symmetry, domain, and range. If you remember the domain, in linears, same thing. What did we say the domain was? The domain refers to all the elements on the axis or in the x-axis. The range refers to all the elements in the y-axis or the y's. Okay? We already saw what the vertex is. The vertex is the minimum point. In this one is facing upward, so the vertex is called the minimum. All right? Okay, like imagine that you have your arms raised up. If you have your arms raised up, what will be your minimum? Maybe your belly button, okay? Or the part of your stomach. Okay. You have to look at where the vertex is. Where is this vertex located? We're going to use a coordinate. Remember, blank, comma, blank. In the form of x, comma, y. On the x-axis, where is this vertex located? At 0. Where is it touching on the y-axis? At 1, 2, 3, 4, negative 5. So it's 0, comma, negative 5. Okay? So that's what we write. Axis of symmetry. All of the parabolas have an axis of symmetry. Here, this one happens to be landing exactly on the y-axis, but I don't want you to get confused, all right? Sometimes the parabola is going to be over here. If the parabola is over here, then your axis of symmetry is not your y-axis. So because of that, I'm going to highlight the axis of symmetry with my green highlighter so you can see it separately, all right? That is your axis of symmetry. I want you to see something, and I want you to do here something with this word. You see the word axis of symmetry? You have the x, make this x big, como la X de Juárez, like the X in Juárez, okay? It's a big X. Why do I want you to do that? Because, first of all, you're going to represent and report that the axis of symmetry is x equals what? Okay? Where are we going to get this value of x? We're going to get it from the vertex, all right? From the x-coordinate of the vertex. This one happens to be a 0, so it means that our axis of symmetry is at 0, where the x equals 0. So let's make this note. The x-coordinate of the vertex is the axis of symmetry. Okay? All right. And now we're going to analyze the domain. Remember, I don't know if you remember with linears, we did this. With linears, we analyze what is the domain. You analyze how the graph behaves. What are the elements of the domain? What are going to be all of the elements of the domain for this graph? Since we're talking about the x's, I'm sliding my paper sideways, horizontally. Because of these two arrowheads, we can see that this graph is going to continue forever and ever and ever and ever in this direction, forever and ever to infinity to the left direction. So the domain, we say that is the set of all real numbers. But on the y-axis, the range is how does the graph behave or exist on the y-axis. Where does this graph exist? If I slide my paper up and down starting from the bottom, do I have a graph here? No graph, no graph, and then I see it here. It starts popping up here. It starts appearing here at -5. And if you see from here, if I draw a line here, if I shade all of this, because I don't have a graph below the -5, I only have a graph above the -5, so from here and up, that's where my graph exists. So how do we describe these numbers? We say that the values of the y are what? Greater, because we're going up. The -4, the -3, the -2, the 2, the 3, the 5, the 10, the 100. Those are numbers that are greater than or equal to -5. And that's how you describe the range. Okay? Now, how do we transform this function? They're talking about how do we transform it, because over here, this will be, let's draw the parent function. This will be the parent function over here, okay? This one in the dotted line, all right? Now, all of the parabolas have an axis of symmetry. All parabolas are symmetric. And I don't think we wrote this. It's talking about characteristics. Sorry, let me move it back again. All parabolas are symmetric. Write it down. And of course, the parabola is the graph of the quadratic. I forgot to mention that from the beginning. If you see the word quadratics, you see the letter U, this will help you remember that the graph is like a U, and it's called a parabola. So let me write it over here. The graph of the quadratic function is the parabola. Okay. That is the graph of g of x when it's x squared. Okay. All right. And then we'll leave this one for your Behringer tomorrow, okay? So you better watch this video, take your notes, because I will leave this one for the Behringer. You're going to have to identify the vertex, the axis of symmetry, the domain, and the range, all right? Same thing that we did over here. And actually, I think we can work on this one. Yeah, I'm just going to give you a little help because we need to stop this video too. So you're going to identify the vertex. Remember that you have to look and you have to report 0, and a number. So actually, no, this is not going to be your Behringer. You're going to do it on your own. So complete with your notes. Okay? They're asking you for the vertex, 0, number. Where is the vertex? Where is it crossing the y-axis? Axis of symmetry. Remember what we wrote over here. Whatever your x-coordinate of the vertex, that is going to be your value for the axis of symmetry. And why do we write it as x equals 0? Because the axis of symmetry is crossing the x-axis at 0. This is where the line is, at 0, for this particular example. For the domain, for all parabolas, upward or downward, the domain is going to be all real numbers. This one is given to you. This one is free. The domain is always going to be all the real numbers. This is where the tricky part comes, okay? The range. Where does the graph exist? Greater than or less than which number, okay? It's pretty easy. Just watch and repeat the example from above. Okay, so you have to send it with your notes. Send this with your notes. Your bell ringer will be a different graph and you'll still have to do the same work. Okay, so send your notes, and that is today's work. All right, guys, and we'll see you tomorrow. Thank you.